Well, hey there. In an earlier video, I showed you how to make a tiny kiln. This little paint can size kiln where you can melt zinc in a ladle, and it's fired by MAP gas through a hole in the bottom. So today, I want to show you how to make a grown-up kiln, at least close to grown-up. So here we go. The basis of this kiln is a garbage can, and you need a lining of this inorganic fiber material called Durablanket. It's a high temperature resistant inorganic fiber, and that insulates the garbage can as you produce heat inside. The Durablanket is then protected with a steel mesh. This is a stainless steel shelving, and inside this kiln you make a cage out of this steel mesh material. The point of the cage is to receive the crucible. So the way it's going to work is that we pack the outside with charcoal, some in the bottom, light it, and then insert the crucible with the metal to be melted into this cage. So when you pull the crucible out after the metal is molten, then the charcoal doesn't fall in and prevent you from putting the crucible back. Now in the bottom, you'll see there's an ash grate, which is about 2 inches above the bottom of the kiln, and it's held up by bolts. Air vents are cut in the bottom below the ash grate, and this is where the air to burn the charcoal will enter. Now, you also need a lid. And like the kiln itself, the lid is lined with this Durablanket. And it goes on top, obviously. And has a place where you can put a chimney. This is just 3-inch stovepipe. And you slip the chimney in here. Whoops, watch out for fluorescent lights. And as the hot air from the charcoal rushes up the chimney, it will create a draft pulling in air from the bottom. So you don't need a fan in order to make this kiln work. Within a fairly short time, you have a kind of a blast furnace inside, because the heat from the burning charcoal can't be lost to the environment because of the insulating blanket. The fuel for melting metal is charcoal, and I prefer briquettes because they are a standard size and they fit nicely between the cage and the protective mesh on the outside. So you fill this space with charcoal, put some in the bottom, light it with some kindling, and when it's going, put in the crucible. Let me say a few things more about the crucibles. These are made from steel scuba tanks that have failed the pressure test, so they can't be used for scuba diving anymore. You can go to a machine shop and they can bandsaw off any length that you want. This is a medium-sized one. There's a shorter one. Whatever suits your purposes. And then what I like to do is have them weld a little loop on the bottom here so that I can pour the molten metal from the crucible, having lifted it with a steel hook. Don't try this with your hands. And then I can hook this little loop with this thing and pour. I can do a single-handed, a pour by myself, which is nice. Another thing you have to be conscious of is that molten metals are corrosive, and a bucket of red-hot aluminum has a solvent action on the inside of the steel crucible, and zinc is much worse. Zinc will corrode all the way through one of these crucibles in 5 or 6 melts. So I found this coating. It's a high temperature refractory coating called, it's a boron nitride. It's actually a slurry of this boron nitride. And I paint the insides of the crucibles, and when it's dry, that coating is repellent to molten metal. Molten metal doesn't wet this coating, so that prevents corrosion of the inside of the steel crucible. As for corrosion on the outside from oxidation, you can see the steel spalling off there. I don't have a really good way of preventing that. There are some coatings, but I've never found them to be terribly effective. So eventually, these crucibles are not eternal. They do burn out, but you can get failed steel scuba tanks essentially for free, so you can always just have another one made. Well, you'll need a hook to pull the crucible out of the kiln. You will also need a spoon with which you scoop the dross that accumulates on the top of the metal and discard that, and then some kind of a hook for hooking the loop. If you're doing a large amount of aluminum, you're going to find that crucible mighty hot, and it will, quite literally, if you get it close to your clothing, it will catch your pants on fire. So a friend gave me these gaiters, which you wrap around your legs. They are pretty good. You might also want a barbecue apron. Yes, a barbecue apron, so you can protect your clothes from the front. And of course, you will definitely want some heat-resistant gloves. These are Kevlar gloves. They no longer make asbestos gloves, but these Kevlar ones are pretty good too, and they're not the latest fashion, but they will allow you to deal with all these sources of heat. You might be wondering also, where do you get enough aluminum for use in such a kiln? It's actually a rather large amount. Well, forget about soft drink cans and beer cans. They have so little metal in them, it's not worth your trouble. My best source of aluminum has been in scuba tanks, aluminum scuba tanks that have failed the pressure test, and they can no longer be used. They have to be scrapped. So you can get a machine shop to cut them into pieces that will fit into the kiln, and then there you go. You can get lots of aluminum. I mean, a tank has probably 35 pounds of aluminum in it. There are differences in the alloys of aluminum. This is a 6000 series alloy, and it has a very high tensile strength, but the disadvantage of it is that it's hard to solder and weld. There are other alloys that are easier to solder and weld. They have different properties of strength, bendability, and tensile strength. If you use aluminum from electrical wires, that's very soft and very easily bent, so that's the other end of it. The thing about aluminum is, if you have aluminum left over that you haven't poured, you have molten aluminum in your crucible, you can always pour it into ingots and reuse it at another time. I mean, that's even if you have a failed cast that's not very good, you can do the same thing. You break it up, you melt it again. I should also say that for safety purposes, you might want to invest in a face shield. People criticize me for this, but these molten metals are very quiet. There's not much, there's no splashing or explosions or anything of that nature, unless you happen to pour it into a cavity that's wet. And then you can get the steam blowing back metal. So in that case, you might want to wear a face shield. And in an hour to an hour and a half, you can have a bucket full of red-hot aluminum ready to pour, preferably not on your feet. And that's it. Nothing to it. I mean, how hard could it be, right?